Hello and welcome to another video from Haybridge High School's Maths Department. In this video I'm going to be doing examples where we use the form y equals mx plus c to draw lines without plotting any values and factorising these lines to find the roots. So first of all, what we need to know before we move on to finding roots and drawing graphs is we need to know the equation of a straight line can be written in the form y equals mx plus c. When it's written in this form, there's two things that we can take from it. So where we have m, this is our gradient of the line, so it's our steepness of the line. And where we have plus c, this is our y-intercept, so the point in which it crosses the y-axis. So I've just got a couple of examples here. So we're just going to make sure that they're in the form of y equals mx plus c, and we're just going to write down what the gradient of the line is and what the y-intercept is. So first example, we've got y equals 2 plus 3x. It's almost in the form. What you can do if you want is put y equals 3x plus 2. That means the same thing, they're just written in a slightly different order, so that's fine, and then that is in our form. So our m value would be 3 because it's the coefficient of x, so that's our gradient, and our plus c value would be 2, so it would intercept our graph on the y-axis at 2, positive 2. So you didn't need to do that. It would be the same if you had left it in the original form. It's up to you whether you would like it to be in the form above. So our second example, we've got x minus y equals 0. So this isn't close to our format that we like, so we just need to rearrange it. So what I'm going to do is I'm just going to add y to both sides. So then I've got x is equal to y. So again, if you really wanted to, you could write it as y equals x, but they mean the same thing. So in this case, our coefficient of x is just 1. We can't see it, but we could write a 1 there if we wanted to. So our gradient would be 1. And plus c value, we haven't actually got a plus value or a negative value. So at this point, it would go through the origin at 0. And last example, so we've got 4x minus 3 is equal to 5y. So again, we could write this as 5y equals 4x minus 3. So it's close, we've got the y on the left-hand side, but we can't leave it like this because y has a coefficient. So it's currently being times by 5. So I'm going to divide both sides by 5 to get my y by itself. So y equals 4 over 5x minus 3 over 5. So now this is in the form that we want it to be, y equals mx plus c. So our m value would just be 4 over 5, and our plus c value would be minus 3 over 5. Make sure you always include the negative. So we don't always write the plus when it's a positive, but when it's a negative, make sure you always include the negative. So what we're going to be doing in this video, we're going to be drawing graphs. Usually what you would do, you would have a table of values and you'd want to put in the value of x as 0, 1, 2, -1 and so on. We're not going to be doing that in this lesson. We're going to do something slightly different. We're going to use the two things that we've just discussed, our gradient and our y-intercept. So in our example, y equals 4x minus 7. Hopefully we should know now that our gradient would be 4 and our y-intercept is minus 7. So what we first of all we need to do, so this is we just label my axis, so this is my x, this is at my y-axis. So our y-intercept talks about the point on this axis here, this horizontal line. So we're saying it would cross this horizontal line at minus 7, so somewhere down here. So to start off with, I would just make a mark on my graph where it crosses the y-intercept, y-axis, apologies. Next thing that we need to do, so our gradient, where it's 4, all this means is every time we go 1 across, we go up 4. So at that point, I would make a point there, and then the same again, it goes across 1, up 4. And then you keep doing this until you've got some sort of a line, and then you would draw in your line. So we go across 1, up 4, so mark there, cross 1, up 4, mark there, cross 1, and up 4. So don't need to do too many because we can see this straight line forming. So this is where you would need your pen and ruler. I unfortunately do not have a pen and ruler, so I'm just going to try and do mine freehand. So you should have something that looks like this. Okay. So next example, so we're going to take the information that we need. So we need the gradient and we need the y-intercept. So we've got the equation y equals minus 5x plus 1. So our gradient will be minus 5 this time. And our y-intercept is 1. So we need to start off by looking at our y-axis. So label our axes, y and x. So y-intercept is 1. So we just make a mark. So we go on our y-intercept positive 1, which is here. So again, when we go across 1, this time it's minus 5. So instead of going up, we go down as it's negative. So we're going to go down 5 this time. So starting off at our y-intercept, we'll go across 1 and down 5. So we'd have a mark there, across 1 and down 5. So let's pop marking our points, across 1, down 5, cross 1, down 5. So at this point, we could go back to our original and go the opposite. So instead of going across, we'll need to go backwards 1. And instead of going down, we go up 5. So to here. But now I can see where my straight line is. I can take my ruler, pencil and ruler, and I can draw in my straight line, which goes through the points that we have drawn. And you should have a straight line that looks like that. So the next example, we've got 2x plus y is equal to 3. So I'm just going to write it over here so I can rearrange it. So we are looking for the form y equals mx plus c. It's currently not in that form, but I could just I could take away 2x from both sides to get my y, make the y the subject. So I'm just going to add below. So we'd be left with y equals 3 minus 2x. It's very much in that form. We could rearrange it if we wanted and write y equals minus 2x plus 3, but either way would be acceptable. So that just means that our gradient would be minus 2 and our y-intercept would be 3. So if we mark off, if we find, looking at our y-axis here, if we find off where 3 would be, positive 3 here, we'd mark there. So it's every time we go across 1, we're going down 2, so it's a negative number, meaning that we're going to go down. It's of 2, so it means we go down 2, so we'd go across 1, down 2, across 1, down 2, and we just mark it off. So if I do that, so I've got my x-axis, y-axis, we intercept at 3, so we put a mark there, we go across 1, down 2, across 1, down 2, across 1, down 2, and keep going. And then once you've got enough lines, we can join it up. So remember, pencil and ruler, we're just going to put a line through. So yours will look a lot better than mine. Keep extending it. Ooh. And you should have a line, something like that. So next example, so we're wanting the form y equals mx plus c. Currently, x is our subject and we want y, so we're just going to need to rearrange it. So we've got x is equal to 2y minus 6. So I'm going to add 6 both sides first, which leaves me with x plus 6 is equal to 2y. And then we need to divide both sides by 2 because y is currently being multiplied by 2. So divide by 2. We would be left with a half. X plus 6 divided by 2 is 3, and y. So we're in the form that we need. It's the other way around, but there's no problem with that. So our gradient is a half, and our y-intercept is 3. So again, we're going to look at our graph. We're going to do our y-intercept first, find where it cuts the y-axis at 3, so it would be roughly here. But instead, so we've been dealing with whole numbers, and this is a half number, so when it gets into fractions, it gets a bit difficult to see, but it's still the same process. We're going to go across 1 and up half. But instead of marking there, I would go across 1 and up another half, and then we know that it's going to be on that point. So I would go across twice. So going across 1 and up half and across 1 and up half is the same as going across 2 and up 1. So we could do across 2 and up 1 and it'll be the same. So we're just going to mark those on. So we've got our x-axis, got our y-axis, we're cutting through at 3. So mark on my 3. So remember it's positive, so we're going to go up. We're going to go across 2 and up 1, make a mark, across 2, up 1, mark, and so on. And then again, I can just draw on my line. You need your pencil and your ruler, and you just need to connect your marks. Oop. And you should have a line that looks like this. So previously we've been looking at when we've been given our equation of a line. Now we've been given our line, it's drawn for us, and we need to find that line. So we need to find y equals mx plus c. So first of all, previously we would mark on where it intersects the y. So to start off with, I would look at our graph and look to see where on this y-axis it cuts the y-axis, and hopefully you'll be able to spot that here is where it crosses. So at that point we know that it's going to be plus 1. So I would just write down that y is equal and plus 1. We just need to find this gradient of x. So to find the gradient, what we need to do, we can either go across 1 and count up how many 2. So we've got across and up 2. So as we're going up 2, we should know that our gradient would be positive 2x, and that would be the equation of our line. What we could also do though is we have a little formula for the gradient, which is m is equal to rise over run. And by rise, what I mean by rise is how far we go up or down, either or, but we're going up positive 2, and our run, so how far do we run across our x-axis? We go across 1 and we go rise 2. So it would be, it's equal to 2 over 1, and 2 over 1 we can just write as 2. So if you're not very confident with just looking at the graph and counting up, we can remember this formula of rise over run, and we can find out our gradient that way. So next example. So again, we're looking for y is equal to mx plus c. So we'll start off by finding the y-intercept. So our y-axis is there, x is there. So where on this line does it cross on the y-axis? Well, it crosses smack bang in the middle. So this is our origin, and we should know that at origin our y value is 0. So we don't actually need to write anything for c because it's 0. So let's move on to finding the gradient. So we can do as we've done previously. So if we knew that it was 2, we'd go across 1 and up 2. Whereas this time it doesn't work, so we need to follow where the line's going. So if we go across 1, we're currently going down 1. So across 1 and down 1. So if it's down, it means that it's going to be a negative, and because we're only going down 1, it just means that our gradient would just be negative 1x. Or we could rewrite that as y is equal to minus x. We can double check by using our gradient of rise over run. So first of all, how far across do we go? We could go, if we start at the origin and we go back 1, so if we go from origin here and back 1 here, we're going minus 1. And if we go then up to do our rise, so we're going to run backwards and rise 1, so it's minus 1 over 1. So if we just write that, so our rise was 1 and we ran backwards, so it would be minus 1. Another way of writing 1 divided by minus 1 is just minus 1, which we have got already. So another example, we're looking for y equals mx plus c. So let's start off by looking at our y-axis. This is our x-axis. So let's look to see where it cuts the y-axis. Well, it's going to be here, which would be minus 6. So we can already write that y is equal to something. Well, it's minus 6, not plus 6. So let's write in minus 6. And then let's pick 2 points on our graph and we'll do our rise over run. So if we pick this point here, and let's pick this point here. So I've picked those points because they're not in the middle, they are a whole number, so they are an exact point. So let's have a look. So if we pick this point here, how far do we run? So we're going across the axes. Well, we go 1, 2. So we can say that, so m is equal to rise over run. So we've currently found that it runs 2. And then so we've gone 1, 2, and then how many do we go up? We go 1. So we know that we rise 1. So that just means our gradient's going to be a half. It's positive, so it's a half x minus 6 is the equation of our line. So another example, so we're looking for the equation of the line, so y equals mx plus c. So let's look at the y-axis and where it cuts the line. So it cuts it at positive 2, so we can write y equals, let's leave a blank, plus 2. For our gradient, we know it is equal to rise over run. So let's pick 2 points. So if we let's pick the y-axis intercept, and let's pick the x-axis intercept. So if we start at the x-axis, do we need to go forward or backwards? Well, we need to go backwards 1. So that's going to be, we run minus 1. And then how many do we need to go up? Well, we go up 2. So it's going to be 2 over minus 1, which is the same as negative 2. So we know our gradient, our m value is minus 2x. So our equation of the line is y equals minus 2x plus 2. Now we're going to be moving on to finding a root, and by finding a root we need to factorise. So by factorising, what do I mean? Hopefully some of you are thinking we need brackets. This means putting things into brackets. So we've just worked out that the equation of this line is y equals minus 2x plus 2. So we need to put the right hand side into brackets. So y equals and brackets. So by doing this, we need to find a common factor in both of our terms. So we've got minus 2x and we've got 2. So we need to pick something that goes into both. Well, hopefully you'll be able to spot that 2 can go into both. So we would just write 2 on the outside of our brackets and open bracket. So what number do we need to times 2 by to get minus 2x? Well, we need to times it by a negative first of all to get us minus 2, and then we need to times it by x. x. So if we just double check and expand that out, we'd get 2 times minus x, which is minus 2x, so all done. So next term we've got plus 2, so what do we times 2 by to get 2? To just 1, and that is factorised. So if we look at this, we just take a moment and look at the graph. So what do I mean by a root? So a root is this point here where the line crosses the x-axis. So this is our root. So this is our x-axis, and this is the bit that we are interested in. And at what point is this here? Well, this is when x is equal to 1. So what we need to do by this factorising is we need to pull out this value of x equals 1. So to do that, we need this bracket here to be equal to 0. So what I would do is I'd write out the inside of the bracket, so minus x plus 1, and I would let it equal to 0 because it's when it's on our x-axis, so y is equal to 0. And I'd just rearrange this to find the value of x. So currently we've got minus x plus 1 equals 0. So I'm gonna add x to both sides, which would leave me with 1 equals x. So we've done the same as drawing the graph and visually seeing that x is equal to 1 on the root of this graph, but we've also done it by factorising. So let's have a go at a few more examples where we're finding the root by factorising. So let's factorise y equals 5x plus 10. So we need to take out a common factor. So what goes into 5x plus 10? Well, a factor of 5 would. So we can write y is equal to 5 and open my bracket. So what do we times 5 by to get 5x? Well, it's x. And what do we times 5 by to get 10? Well, it's plus 2. So again, this is my next step. I'm going to take what's in the brackets and let it equal to 0. And then I'm going to take away 2 from both sides to get x by itself. So x is equal to minus 2. So let's do another one. So we've got y is equal to 5x minus 5. So what factor can we take out from 5x and minus 5? Well, we can take out 5 again. So what do we times 5 by to get 5x? It would be x. And what do we times 5 by to get minus 5? It would be minus 1. We'll take that extra step. So x is minus 1 equal to 0. I'm going to add 1 to both sides to get x as my subject. So x is equal to 1. So hopefully that you're now noticing that the root of these lines is just the inverse value of in the bracket. So currently it's positive 2, but x is the inverse to positive 2, which is minus 2. So second example, we had x minus 1, x would be 1. So what's happening there is we're just trying to make the bracket equal to 0. So what value does x need to be for it to be 0? So another example, we've got y equals minus 7x minus 14. So we need to take out a common factor from minus 7 and minus 14. So I can take out minus 7. What do I times minus 7 by to get minus 7x? It would just be x. And what do I times minus 7 by to get minus 14? It should be 2. So without me letting this brackets equal to 0, hopefully now you can just see that x is equal to minus 2. Because if we were to substitute in the value of x as minus 2, it would then mean the equation is all equal to 0. So we would have minus 7 minus 2 plus 2. And then this would just become 0. And then the whole equation would be 0. So hopefully now you can just see that extra step without having to do the working out. So next example, we've got y equals 9 plus 6x. So let's take a common factor of 9 and 6, which will be 3. 3 times what gets you 9? Well, it's 3. So 3 times what gets you 6x, which is 2x. So this one's slightly tricky, but we should be able to do the same. So it needs to be the inverse, so x needs to be a negative value, but it's going to be a fraction this time because it needs to be taken in the coefficient of x, so it's going to be minus 3 over 2. So just to show you, it would be 3 plus 2x is equal to 0. We need to minus 3 from both sides, getting you 2x minus 3. And then we want x by itself, so we're going to divide by 2 both sides. So we've got minus 3 over 2. Okay, so that's all for today's video. Thank you for watching.